If you like this video, be sure to subscribe and hit the bell icon. Share it with a friend and I'll be doing more videos like this just for you. Science 10 Module 3 Geologic Features that occur along the plate boundaries. Hello students! In the previous module, you learned about the different types of plate boundaries. In this module, you will learn about the processes that occur along these plate boundaries. You will also learn about the different geologic features and events that form along these boundaries. Have you ever wondered how the mountains and volcanoes were formed? How about ridges and trenches? What causes earthquakes and tsunamis? We will find out the answers to these questions in this module. In the previous lesson, you learned about the types of plate boundaries. Can you recall what these are? Number 1. Blank is a boundary in which two plates move towards each other, causing one of the slabs of the lithosphere to subduct beneath an overriding plate. The correct answer is convergent boundaries. Question number 2. A region where the crustal plates are moving apart. What type of boundary it is? The correct answer is divergent plate boundaries. Question number 3. A boundary produced when two plates slide past each other. Name the type of boundary. The correct answer is transform plate boundary. For today's objectives, we have number 1. Explain the processes that occur along the convergent boundaries. 2. Determine the consequences of colliding plates. And 3. Determine the geologic features or events that occur along these boundaries. Study the picture showing a cross-sectional diagram of plates that are converging. So, what did you observe? You've learned from the previous module what happens during the collision of two plates between a continental plate and an oceanic plate. From the diagram, it is clear that this event leads to the formation of volcanic arc near the edge of the continental leading plate. What causes this? The denser oceanic crust undergoes subduction or the bending of the crust towards the mantle. Since the mantle is hot, the crust melts, thereby forming magma. The addition of volatile materials such as water causes the magma to become less dense and rise to reach the crust. This process leads to the formation of volcanoes on the continental leading plate. Another subsequent effect of the grinding of plates against each other is the occurrence of earthquakes. The subduction of the plate can cause earthquakes at varying depths. For the oceanic crust, an important geologic feature is formed, and that is the trench, also called submarine valleys. Ocean trenches are the deepest part of the ocean. One of the deepest is the Philippine Trench with a depth of 10,540 meters. Study the picture showing a cross-section of two converging oceanic plates. Using your knowledge gained from the previous activity, identify the geologic events or features resulting from this collision. Like the first type of convergent boundaries discussed earlier, converging oceanic plates will cause formation of trenches, and these trenches will cause earthquakes. Underwater earthquakes can generate tsunamis, which means harbor wave in Japanese. A tsunami is a series of ocean waves with a long wavelengths, typically hundreds of kilometers, caused by large-scale disturbances of the ocean. The leading edge of the subducted plate will eventually reach the mantle, causing it to melt and turn into magma. The molten material will rise to the surface, creating a volcanic island arc parallel to the trench. Volcanic island arc is a chain of volcanoes positioned in the arc shape as seen in the picture. Many parts of the Philippines originated from oceanic convergence. This resulted from the collision of two oceanic plates, with one of the plates subducting under the other. Mayon volcano in Bicol is a subduction zone volcano forming above the subducting Philippine sea plates. Majority of the islands in the Philippine archipelago are considered part of the Philippine Mobile Belt. These islands were formed 65 million years ago at the southern edge of the Philippine sea plates and are considered part of the island arcs. Palawan, Mindoro, and the Zamboanga Peninsula are all highland sections of the Sandalan Block of the Eurasian Plate as shown. The Philippine Mobile Belt eventually collided with the Sandalan Block, which explained the presence of trenches such as the Manila Negros Cotabato Trench System and the Sulut Trench. On the eastern side of the Philippines, trenches like the Philippine Trench and East Luzon Trough are both products of the subducting Philippine sea plates beneath the archipelago. Aside from the formation of trenches and troughs, the downward movement of oceanic lithospheres underneath the Philippine archipelago creates active volcano change. For example, the subduction of the West Philippine Sea oceanic lithosphere along the Manila Trench created a volcanic chain from Taiwan to Mindoro, including Pinatubo in central Luzon and Taal in Batangas. Also, the constant tipping movement of slabs induces frequent moderate to strong earthquakes at various depths and give rise to mountain ranges. When two continental plates converge, a collision zone is formed. Since they are both less dense, no subduction occurs. This collision leads to the formation of mountain ranges and the occurrence of shallow earthquakes. About 40 to 50 million years ago, two large land masses, India and Eurasia, collided to begin the formation of the Himalayas. Since subduction is impossible with two colliding continental plates, pressure is released by pushing the crust upward and forming the Himalayan peaks. This time, let's analyze the photographs of a rift valley and an oceanic ridge. The formation of rift valleys and oceanic ridges are indication that the crust is spreading or splitting apart. In this case, the plates are forming divergent plate boundaries wherein they tend to move apart. Most divergent boundaries are situated along underwater mountain ranges called oceanic ridges. As the plates separate, new materials from the mantle ooze and slowly become new ocean floor. Although a very slow process, the divergence of plate ensures a continuous supply of a new material from the mantle. The spreading rate at these ridges may vary from 2 to 20 cm per year. When a spreading center develops within a continent, the crust may break into several segments. The breaking leads to the formation of down-faulted valleys called rift valleys and to the rising of hot materials from the mantle. The rift valley increases its length and depth as the spreading continues. At this point, the valley develops into a linear sea, like the Red Sea today. Study the picture showing transformed fault boundaries. Liken it to a piece of biscuit whose top layer is broken and one part is sliding horizontally past the other half. The diagram depicts transformed fault boundaries where two plates are moving horizontally past each other. Such areas are usually free of volcanic activity but are extremely prone to earthquakes. As the plates are kilometers thick, the rocks within the plates tend to grind against each other as they slide past, and the plates may become jammed. This puts tremendous stress on the rock within the plate, which may build up for centuries. These rocks can stretch up to a point, elastic rebound, but will eventually snap along a fault line. This is known as a transformed fault. It releases seismic waves to the surface to cause an earthquake. An example of this is the San Andreas Fault in California, USA. Cities such as San Francisco and San Diego are affected by seismic activity along this line. These cities lie directly above the focus known as the epicenter and suffer the most damage. Strong fault boundaries cause earthquakes that are triggered by movements along the fault system. Majority of tectonic activities like earthquakes, mountain formations, volcanic activities happen along or near plate boundaries. But there are some activities that takes place in the middle of the plate. Let's take the case of the Hawaiian Islands, where we can find some of the largest and most active volcanoes in the world. If we look at Hawaii, it is situated right in the middle of the Pacific Plate and not along the plate boundaries. What causes the formation of this chain of volcanic islands? The answer lies in the area called a hotspot. Hotspot is a region deep in the Earth's mantle from which heat rises through the process of convection. This heat facilitates the melting of rock, magma, which then push upward through the Earth's crust to form volcanoes. Scientists suggested that there is a fixed source of molten materials from the mantle called mantle plume, located below a hotspot that form the volcanic island chains. As the Pacific plates move northwest at a rate of 3 to 4 inches a year, different parts of it will be on top of the mantle plume to receive the molten materials, thus creating the volcanic islands. This plate movement carries volcano after volcano away from the fixed hot spot like a conveyor belt. We are aware that our country is prone to natural disasters like earthquakes, volcanic eruptions, and tsunamis. Thus, it is a must for us to prepare and ensure our safety when these disasters strike. For this activity, your goal is to help your family prepare for an emergency. Your task is to prepare an emergency kit for the whole family. What items should be in your emergency kit? List them below. Why do you choose this item? Don't forget to submit your answers in our agreed platform. Thanks for watching. Don't forget to like, and if you're new in this channel, click subscribe to be notified with more videos like this. See you on my next video. Goodbye.